There are several different types of attacks that you're going to encounter that have to do with the bad guys, the ne'er-do-wells, actually spoofing information, putting in information such as email addresses or telephone numbers or web addresses, things like that, that are it's false information. Right? I've even had situations, and my wife has as well, to where telephone, spoof telephone calls coming in on my phone number from me, where it would show up the incoming name on the telephone call was me. So, which was disconcerting, when you get a call from yourself like that. Have you ever had that happen?
Nope.
Yeah, it's really weird. The wife and I both. Now, I think ours was a result of Target stores had a large data breach a couple of years ago, and my wife's information and thus mine was actually stolen as part of that data breach. And we know all that, not just ours, but everybody else's information is being sold out on the public internet now all over the place. So, it's just crazy stuff. I get emails from myself, and I've still got four different email addresses that I use regularly. And I get emails with the email address coming from me, so very strange there. Spoofing attacks are designed in order to disguise the true user, the true hacker and attacker there. And they can do it in a number of ways. I mean, all of this is digital data, your voice over IP phone calls, your emails, text messages, everything. But we see, in addition to those kinds of things, we email spoofing, text messaging spoofing. We see internet protocol, IP, like voice over IP, video over IP. We see spoofing attacks that are performed by way of corrupting the ARP cache, call it ARP poisoning. And remember, the ARP cache is what associates your MAC address with your IP address for the duration of your session. So if that information is compromised on your system, and same thing with the DNS cache, your DNS host file, if that is compromised and there's information that is overlaid on the legitimate data, it's a spoofing type of attack. And those things are used to get around, sort of find a backdoor or bypass specific security controls that are available. Those things are used to fool users into clicking links, things like that. So we need to train our user base, especially employee type users, as it relates to spam emails and spam type text messages, to be able to look sort of under the covers, any links that are associated with text messages and email addresses, and it's unsolicited emails or unsolicited text. Well, our employee base and our users need to be trained. Don't click the links, because that still accounts for probably the great majority of malware that gets introduced into computer systems of every type, is because people are clicking these malicious links, and it downloads information directly onto those systems. Now, I spoke yesterday in passing about the man in the middle attacks. There's a man in the middle attacks. There's man in the browser attacks. These are referred to as on path types of attacks. It's actually a multifaceted setup where you get into that particular type of attack. Session hijacking is one such way that that's performed. And one version of that is, using a tool like a Wireshark, and I'm sitting sort of off to the side. I've been able to compromise a host machine, or been able to tap into a communications port on a hub or something like that. And I'm able to watch the data that's flowing back and forth between the end systems, the individual host machines there. Well, if I can intercept that information and change the data, then I can control that communication session. Oftentimes do that by spoofing IP address of what would normally be the gateway device. So the users think they're talking to the gateway, but they're actually, the communication session is going through my system. And I can change that to say whatever I want it to. Another version. Let's say I'm looking at a communication of a user And I'm sort of sitting beside and, using a tool like Wireshark or TCP dump to capture those data frames. And I see a user has logged into a website that they intend to do some type of purchase some product or service with, banking, whatever. So I scrape some graphics or some branding off of the site that they're attached to. And I've also done some background research and gathered an email address for that user. I may have been watching this user for a couple of days. So I send a sideline email to the user that says something to the effect of, notice you just logged into our website here at Bank of whomever. And again, I got the logo and the brand on the email. Well, there may be a security problem with your link. Click this link to validate your credentials. So when they click the link, I do a couple of things. I download some malware onto their system that allows me initially to grab that cookie file that they use to validate to that website. So immediately I can hijack that session. But I will also then redirect them with that link to a bogus website that I have created, also using the branding and the logo of the legitimate site to get them to validate their credentials, i.e., give me their user ID and password. That's another on-path type of attack that I'm talking about there. And I can set those up in a number of ways. I can do that packet capture with the tools Wireshark. I can do it by intercepting data and data packets that are in the wireless Wi-Fi eavesdropping, they call it. There's a whole packet of tools that are utilized in the wireless arena called Aircrack NG. And same kind of thing. I can packet capture. I can send a deauthentication packet. I can interrupt the communications. So those are very, very common types of real-time on-path attacks that we see attempted, in many cases successful, injecting packets, data frames, packets, malware right in line into a communication session. Okay. Here is an example, top to bottom, of an ARP spoofing attack. Okay. The information here, that is the MAC address of the destination or the target system. Okay. Now, I've highlighted the item up here. That tells me the IP address. This reveals the MAC address down here. Okay. Well, if I use either the IP address or the MAC address and can position myself in the middle of that conversation, well, I have complete flow control of that. Now, in this case, I'm just changing the MAC address that would be associated with the IP, or vice versa. So I can use that to redirect traffic, you see. So if I jump in the middle of this particular conversation, intercept the packet, change the information, spoof my MAC address or another MAC address, I can redirect traffic. Okay. So another example of that on-path type of attack there. Now, I mentioned a couple of times day before yesterday, we were talking about the new managed multi-layer switches. The new managed multi-layer switches don't act like the old hub devices, so it's not one large broadcast domain. The older hub devices, anytime you broadcast a packet into any of the ports, it broadcasts it automatically out to all of the other ports. And then each individual system there had to determine, well, is that data packet from me? If it is, I'll process it and respond. If it's not, I just ignore it, but I get it every time. Now, the newer managed multi-layer switches, excuse me, they don't operate like that. They don't broadcast every data frame to every port on the switch. There's two different functions that are used there to manage that. Most of those switches have what's referred to as a TAP port, a test access port, or a mirror port, it's sometimes called. And on that one port alone is mirror copies of all of the data broadcasts. But inside of the switch, as part of the firmware and the underlying components of the switch, they maintain what's called a CAM table, CAM, Content Access Management Table. Every time a host computer is physically plugged up to one of the ports on that switch, the MAC address of that system is introduced into this CAM table. So it knows the specific MAC address of each and every computer that's hooked up to each and every port on the switch. Now, if I want to force that switch to fallback mode or default mode so that it does indeed start acting like a hub device and broadcasting everything on every port, I can do what's called a MAC flood. So I have a program, typically a application program that's just churning through and introducing connect packets to the switch that says, all right, here's a bogus MAC address and I've just attached to port 1. Here's a bogus MAC address attached to port 2. And it fills up that CAM table. Okay. And it's called a MAC flood because I overwhelm the CAM table and it forces the switch to fallback mode. It starts acting like the default broadcast hub. Therefore, whatever port I am physically connected to, I get all of the data feeds between any and all of the ports that are communicating on that device. Okay? Called a MAC flood. So that gives me all the information of all the data frames, and then I can use a tool like this, Wireshark, to actually see all of that data. Okay? Now, otherwise, I would have to gain access and to tap into or to plug into the tap port or the mirror port in order to be able to see all that data. So again, most of these attacks you'll probably already recognize are multifaceted, multi-step attacks. There's oftentimes a couple of things I need to do to set those up and then start getting the benefit out of those, you see. So that's that. Now, VLAN, I spoke briefly about the virtual local area networks the other day. VLAN is a very interesting concept with these new managed multi-layer switches. A virtual local area network is a subdivision, if you will, of individual ports on the same switch, but then I assign those to a logical virtual local area network definition. And I can create dozens and dozens of VLANs on the same switch. Well, let's say I have a switch that's got, let's say, 24 ports. I've got 24 computer systems plugged into the same piece of equipment, but I go in and create a definition down at the command level language, VLAN 10. And then I assign the computers that are hooked into ports 2 through 14 are VLAN 10. Now, when I'm setting up my local area networks using individual physical pieces of equipment, I typically isolate them departmentally or divisionally. Okay. So I'll have a LAN or a subnet LAN for the HR department, a subnetted LAN type of environment, subsegmentation of the IT division, the accounting group, the customer support reps, that kind of thing. Do the same thing with the VLANs, but on the same piece of equipment. So it really cuts down with these new multi-layer switches, managed switches they call. It really cuts down on the required number of individual pieces of equipment, but gives me the same capability of further isolating my users with the different virtual local area network definitions. Okay. Now, that also gives me the ability, I can hook up multiple switches in the same location or in different locations, but then what they call it trunking those together. So I dedicate typically a couple of ports on each of the switches and physically hardwire the switches together. Well, that also gives me the ability of spreading those VLANs across multiple pieces of equipment if I wish. So it really negates the need to have all of the systems in a singular location because of that virtual local area network definition. So I can have some computers on switch 1 that's in VLAN 10, a couple of computers on switch 2 and switch 3 or whatever. As long as those switches can see one another by way of those trunk lines, I can do that. Now, if I am wanting to communicate from VLAN 10 on switch 1 to a computer that's on VLAN 20 on switch 2, I have to tag that data packet with the return address information in essence, so that the computer on switch 2 knows that the return path is back through one of the trunk lines. Okay. Way of actual that VLAN escape or that VLAN hopping is I have tools that will allow me to construct the data frame and the packet, but give it 2 separate tags. And one of the tags may be a trunk tag. So if I can go across the boundary of those switches, I can hop from one VLAN to another VLAN to another VLAN. Okay? It's called VLAN hopping. Okay? So that's another very common type of attack that I can set up. And if you secure the environment properly and you don't have unassigned port numbers on the switches themselves, if you don't assign port numbers specifically to a VLAN, they belong to a default VLAN. It's VLAN 1. And almost all I guess all the manufacturers of these managed multi-layer switches maintain that default VLAN 1. So if I don't assign those, all the unused ports go switch to switch to switch on any ones that I have trunked together, and they all belong to VLAN 1. Okay. So I can use that couple of underlying techniques there in order to allow me sort of VLAN escape or VLAN hopping kind of environments there. Okay. All right, let's fill in the blanks here, my good sir. Let's see, two types of VLAN hopping attack. Well, I just gave you the answer. Sorry.
That's okay. I already had answered that one in my head.
Yeah. Yeah, those are the different types of hopping attacks. There was fill in the blank. So, like I say, I gave that one away. What type of attack involves intercepting and possibly alerting two parties' communications without detection?
Man in the middle, on
Yeah,
path.
that's one of them, but the type of attack is called an on-path attack. Yeah, man in the middle, man in the browser. Those are on-path types of attacks there. Okay. And then finally, what type of flooding attack overloads the switch's CAM table with many addresses, causing the switch to go back to broadcast default mode? A MAC flood attack, a MAC flooding attack.
Okay.
Yeah, that's where I basically use up all of the placeholders in the CAM table and it makes the switch itself fall back to its default broadcast mode. Okay. So, but I have to fill up the CAM table in order to have it do that. Let's see. I just try that again, and from there. Now, in order to further on this lesson here, there are certain types of external systems or even internal systems that have not been configured properly that oftentimes offer up and define what we call these rogue system attacks here. Okay. Rogue system attacks, by definition, are those that are utilizing or configured with unauthorized hardware components, unauthorized software components. The way that the software components or the hardware components are configured to allow them unauthorized network connectivity. Sometimes because of the certain type of component, may have elevated privileges, okay, or the systems are allowed to connect using service profiles that, you have individual user profiles, you have group profiles, and then you have system service profiles. And any of those need credentials. Well, if I can use those service credentials to attach some of this unauthorized hardware and software, it may give me some of that under the covers access to the system. Serious security risk there.
So evil twin would be a rogue device.
Say again?
So evil twin would be a rogue device.
Yeah, evil twin is a type of rogue appliance. And what did you mention now? I'll give you an example. I worked with the company downtown Atlanta. I've mentioned several times here. We went in to do a security evaluation, top to bottom in their environment. And I used a tool. It's actually a wireless tool that it's a Wi-Fi analyzer, they call it. I have it running on my mobile phone and on my tablet device. But it looks in the wireless world for the SSIDs of all the systems that are broadcasting their ID out in the network. And we also had a listing of all their legitimate devices that they had identified on whomever had set their networks up prior to us getting there. We located 3 rogue appliances. Two of them were wireless. One of them was a wired access point. The wired router access point gateway device, it was duct taped in the back corner of a vacant office space, and it was plugged into the wall. And you know, and we there when we located it, there wasn't anything plugged up to it. So at that point in time, there wasn't any access through it. But we found two wireless access points. One of those was also duct taped underneath the back corner of an. You've seen these cube spaces that will accommodate 3, 4 different users in the same cube space, big one. This was duct taped in the back corner underneath that. It was broadcasting out. And then the other one was up in ceiling tiles in this large, this common area they used for lunchroom, conference room, that kind of thing. And it was broadcasting. And the naming conventions there were so cleverly done. Let me show you what the example of what this stuff looked like here. Okay, let's say that the legitimate device name was, we'll just say WAP123. Okay. The rogue device, the evil twin there, they called it WAPL23. Okay. Now, if you're looking at those two right, you know, together on your little small area where you see the SSIDs that are being broadcast, you can't tell the difference. Now, we never did figure out who put those things there, how long they had been there, how many people had been tricked to hooking up to those things, but we did locate them and we did pull them out. Okay, so that's rogue devices. And all three of those were used in some form to try to fool people into connecting to those, I'm guessing with the purpose of redirecting traffic or to get people to give them the passcode to the legitimate devices. Okay. So yeah, those are called rogue devices, and evil twins was the name of those things. But they're unauthorized. They're not, you know, they're not legitimate devices as far as the networking environment goes. That's why you need, excuse me, you need to do a regular security audit of systems, because it is so very simple, especially in medium to large size companies. It is so very simple for rogue people to get in and plant and reconfigure these rogue devices in there. Evil twins are not just the rogue access points and devices there. Same thing with some of your network services, DHCP, DNS, LDAP services, things like that. The DHCP server and the attack on that is either going in and flooding and changing the available pool of available IP addresses, setting up and corrupting the network parameters, the whole network configuration, the subnetting, the way that the DHCP server services certain segments or subnets or subsegments of the entire network itself. Okay, and the result of it is they're either, you know, stealing traffic, redirecting traffic to, again, rogue appliances that may be capturing information. It may be setting up for those man in the middle or man in the browser types of attacks. And those, again, some of the on-path attacks, intercepting information, changing message data. People think they're talking directly to one another when they're going through a rogue device that is acting like it's a gateway appliance. So all data goes through that. Now, again, all of those types of attacks are multi-point setups in order to make those things successful. So I mean, it's not, you know, it's not easy to do, but it is simple to do as far as complexity and concept. But again, multi-step, multifaceted kinds of attacks there. Okay? DNS, same thing. I mentioned your DNS server is what contains a full-on database that has all of the fully qualified computer systems and host system names with their associated current IP address. If I go in, say if I can gain access to a DNS server inside of even a medium-sized network, corrupt the DNS database, change all of the IPs for every entry in that entire database to all point to one singular IP address, then any and everybody that is in that network Anytime any computer systems that they attempt to communicate with, it's directing all that traffic back to the same IP, overwhelms it, crashes it. That's that distributed denial of service attack that I'm talking about there. Now, remember too, we also spoke about on the individual host machine, you have the DNS cache areas, and it's your host file, HOSTS file. That is dynamic, and it constantly is updated with the DNS, ever-changing DNS information. The fully qualified host name with its current IP address, session level IP address. Well, if I can go in and poison that, again, I can redirect traffic. Okay. And I can redirect it to web servers, to individual host machines, wherever I want it to go. I can just black hole the traffic if I want to, so nobody has any connectivity capability. Now, there's another type of DNS attack that, and this is more sophisticated, more difficult to actually set up. But setting up a bogus website that looks and acts and feels just like a legitimate site, and then gaining access to the DNS cache of the DNS server and changing the IP address of the legitimate site to point to the IP address of the illegitimate site, which again, I've designed to look, act, and feel and program it just like whatever site was a legitimate site. That was done on a couple of banking institutions when the internet first started, or when banking institutions first started doing banking business online. And in that particular case, they called it typo hijacking. People, some of the banks, rather than using their full bank name, they use their acronym, and the bad guys set up the typo, function of whatever their 3-4 letter acronym was, and created a website that looked just like their legitimate site. But when people would click typos, they were directed to this site, and they just handed over their credentials. And by late that afternoon, their accounts were cleared out. Okay. All right, another version of this here, sir. 2 truths and a lie. Okay. I'm going to read all of them, and you tell me which one is the lie. Rogue devices and services are unauthorized hardware and software that connect to a network without permission, potentially causing serious security risks. DNS attacks target the system which translates domain names into IP addresses, undermining the integrity and availability of internet services. And finally, rogue DNS server attacks involve an unauthorized server distributing incorrect network addresses to clients. Which is the lie?
Rogue DNS server attacks involve an unauthorized server distributing incorrect network
Yes,
addresses.
indeed. Very
That's
good,
actually a
sir.
DHCP attack.
Very good, sir. Yes, indeed. Rogue DNS server attacks. That's the lie. The other two are absolutely true. No doubt about it. Well done, sir. Well done. Now, here's one of my very favorite subjects. Social engineering is a term that we hear very often, as a matter of fact. Social engineering is also oftentimes referred to as hacking the human. The human being is by far, the largest target when we start trying to set up a penetration test. No doubt about it. Okay. The human being is most susceptible to certain types of attacks. Okay. Now, social engineering it's a whole host of techniques, so we call it TTPs, tactics, techniques, and procedures that are utilized to exploit human beings, vulnerabilities, and is not necessarily targeted towards technologies or technical issues. It is targeted towards the human being themselves. You should do a search on YouTube sometime. I found these videos some time ago, and it was they were doing just basically a whole bunch of stuff to highlight how easy it was to hack humans. And Jimmy Kimmel, I think, was the show, and one of his young ladies, that was one of his producers, took a camera crew out on the streets of New York City, and they were just doing these man on the street interviews, if you will. And within 5 minutes of talking to a whole range of people, different ages, different backgrounds and everything, Within 5 minutes of talking to those people, the people were giving this lady the PIN codes for their phones, the passwords for their Facebook accounts, PIN codes for their bank accounts. I mean, you name it, they were just giving it away, you know. And it was one of those. I remember the old Connie Chung thing, between you and me deals. And it is so very simple to take advantage of human nature, and that's exactly what this user was doing, no doubt about it. Okay. Social engineering, the goal there is to trick individuals into acting in ways that they normally wouldn't act, or in divulging information that they normally wouldn't give up. Okay? There's several different methods and modes that we see that are targeted towards social engineering. There are social engineers that concentrate on trying to trick people out of giving up passwords. There are social engineering techniques that concentrate on tricking people into clicking unsolicited links on spam email and spam text messages. Okay. And I mean, people's nature, in essence, is they typically trust, others. Um, and it also utilizes a bunch of different techniques that, there's, well, I'll give you an example, giving you a perfect example here. One, I see you logged in as an audit student. Your microphone is hot there. If you would please mute that, I would appreciate it there. Here's an example. Telephone rings. The chief financial officer of a company actually answers the phone, and a dude on the other end of that phone, hi, Mrs. Wilson, this is Dave down in tech support. James told me to give you guys a call up there on the 38th floor. Our systems may be under attack right now. I need to evaluate your systems and plant some walls up there, strengthen your firewall, because it looks like we're under attack right now. So it's sort of urgent that we get this done quick. I know it's a little bit out of the ordinary. James told me to give you guys a call. If you can just give me your user ID and password, I'll log into your system and I'll put this fix in. Then I have to do Mr. Cagle's system and this Ms. Higginbotham system, and then I got to do a couple of other folks on the 38th there. Ms. Wilson, I know it's a little bit out of ordinary, but can you help me out here and save me a trip to the 38th floor? Well, old Dave, which we know his name's not Dave anyway, he used all the right things. He had that urgency. He was very formalized in his speaking patterns. He addressed her formally by her title. He knew that she worked on the 38th floor. He also made reference to people that she knew, familiarity kind of thing. Miss Cagle and Mr. Higginbotham. So it's got to be legit, right? And Miss Wilson, chief financial officer, she's thinking CFO stuff. And old Dave, he did all the right things there. That urgency, that we got to get it done right now, and made reference to James, who she knows James is the director of tech. She doesn't know David from Adam's house cat. But with all of those combined social engineering techniques, 9 times out of 10, old buddy Dave just ended up with the user ID and password of the chief financial officer of the company. Now, just imagine what kind of access to underlying information, highly sensitive information in some cases, that you could get if you have the chief financial officer's user ID and password. You see, that's how it happens. That's social engineering to the nth degree. And these things are very highly effective, mainly because of human nature. Okay? And there's other versions of it too. We've got the phishing techniques that I talked about, spam phishing techniques, phishing for information in general. We've got your piggybacking tailgating. That's where you're following somebody through the door. Piggybacking is when they know, oh, geez, I forgot my card. Can you let me get in today? I don't want to get in trouble, and I swear I won't tell anybody, and I won't forget my card tomorrow either. That's piggybacking. Tailgating is when you slip through behind somebody without their knowledge. Okay. Here's another one, dumpster diving. There was one of our roving reporters here in the greater Atlanta area. This has been several years back. He was doing a series of security segments there. He literally went dumpster diving in the back of some of the medical institutions in the greater Atlanta area, nursing homes, drugstores, hospitals, these little McDoctors, the little emergency room in the strip malls, things like that. This guy came out with mountains, literal mountains of printed reports that had that acronym data I spoke about earlier, the personally identifiable information, prescription data, professional medical information, personal health. I mean, and the list goes on and on and on, diagnostics and so on. Those things are required by federal law to be destroyed. Okay. They just had thrown them away in the dumpsters. There were several major medical institutions that are based in the Southeast were fined hundreds of thousands of dollars because of that reporting. Okay. Other things, peeking over somebody's shoulder will I key in their PIN codes and their passcodes. We've even seen drone devices, UAVs, that now they're hovering outside the office window on the 12th floor, watching people key in their PIN codes or passwords, user IDs and passwords, or taking video of people keying in the PIN code to get into the network ops center, things like that. Those are all social engineering techniques and attacks. Okay? Now, passwords, another large target of the ne'er-do-wells. There are three major types of password attacks that we see launched. One right out of the gate is called a brute force attack. You have a computer program that just spins through every conceivable combination of a passcode and trying to match it up with a listing of user ID, just spins through it. Dictionary attack, same kind of thing, but it uses a predefined listing of dictionary terms and words that are known to be used as passwords. In some cases, it just goes through the whole dictionary, trying to see if there's one of the dictionary terms that are being used as a password. Now, another version of that is referred to as a rainbow table attack. I mentioned earlier the hashing algorithms. Most of your modernized database engines don't store passwords in clear text format anymore. They will use a selection of different hashing algorithms. And when somebody keys in a password, it will create they call it a message digest or a hash of that password. And that's what's stored in the database. So they'll use this program, and whatever the hashing algorithm is, RC4, MD5, SHA128, whatever, they will use that to create the hash copies of all the dictionary terms and then attempt to match those up with IDs. And the computer program spins through that stuff pretty rapidly. Okay. And I mean, the purpose of it is to bypass the credential validation or to hit on, just happenstance hit on some valid user ID and password combination. Now that can be thwarted pretty easily, as a matter of fact, by network engineers just shutting down. 3 invalid login attempts, you lock the workstation up. I'm going to give you a link to, or I'll just tell you about it. There are several different password cracking tool suites. Many of them are open source. Excuse me. There's one called John the Ripper, very commonly used. There's another one called Medusa, another one called Hydra. TCP Hydra, I think, is the new version of it. There's one that used to be called Cain and Abel. It's now just called Cain. But these are programs that are used to attempt these password cracking routines here. And most of them are multifaceted. Now they'll attempt all of them. Now it's more and more difficult to do those on-path types of attacks, in that the savvy network engineers shut the workstation down after 3 or 5 invalid login attempts. So what the ne'er-do-wells will attempt to do is to steal the password file from the database and then take it offline, trying to do the password cracking algorithms there as well. Okay? So summarizing this thing, we talked about policies, procedures. We talked about the all of the controls that we select to put in place should have some type of, at the very least, dotted line connectivity in support of one or all of the pillars of the CIA triad: confidentiality, integrity, and availability. And we talked about different methods that support different ones of those, and some of them support two, some of them support all three. We talked about using individual tools that allow us um, to do real-time assessment and hopefully throw up red flags and triggers during the monitoring process that are designed to alert us to an impending attack attempt. There's three basic types of controls when you look at it and break it down. There are preventative type controls that are designed to prevent attack from occurring. There are detective controls that are designed to alert us when an attack is in place. And then there are corrective controls that are designed to fix it after the fact. Think about like a data restoration function. That's a corrective control. If somebody attacks and scrambles my data, well, I go to my data backup and restore that data, a corrective control. And then, in my opinion, one of the most absolutely effective means of tamping down vulnerabilities and risks that are associated with those vulnerabilities is regular, cyclical, user level security awareness training programs. Okay. And one of the biggest things that we need to train our individual end users on is the understanding of and being able to very rapidly recognize social engineering techniques, and all the ones we talked about. You know, the old buddy Dave calling up and pretending to be somebody else. I worked with a company for a long time that did pen testing and vulnerability assessments. And one of the things that I always loved to do when I was doing my reconnoiter in the beginning of a pen test, I would call, for instance, IT people up in whatever the target company was. And I would, I'd know some of them or know the names of some of the people there, but I would call up and pretend to be a software engineer or a software salesperson. So I'd, get somebody on the line. Hey, Doug, this is Joe Blow with ABC Software here. I understand you guys are running our operating environment there, and I just wanted to talk to somebody that could, you give me the real deal there. And I talked with Doug, your buddy Doug. Oh yeah, Doug, and I know Doug a long time. He was telling me if I wanted to get the real scoop from somebody that knew what they were doing, that I need to talk with you. Does that sound about right? So I've stroked old buddy there, a little bit, and he's going to start giving me a whole lot of valuable information there because he thinks his information and opinion are high rated now. So it's amazing how much information you can get by those types of conversations. It's also amazing how much information you can glean in your reconnaissance step there by just looking at the data, the information that is displayed on the company's forward-facing website. You want to find out what technologies they use? Look at their job recs. If they're advertising for programmers or analysts or database administrators, they'll tell you everything you need to know about their technologies. Okay. So just some techniques there that we utilize in order to try to get that information. A well-trained user base will know how to guard against those specific social engineering attacks.